Given this 4-term polynomial function, we're going to list all of the possible rational zeros. Okay, the PRZ. And the way to do that is we're going to make fractions, and it's going to be all of the factors of the constant term over the factors of the leading coefficient. So first, let's find all of the factors of the constant term. Okay, I'll do it in green over here. So 175. It could be 1 and 175. Let's see, 2 is not going to go in there. So I'm using my calculator now. 175 divided by 3. Nope, that doesn't work. 175 divided by 4 doesn't work. 175 divided by 5. There we go. 5 and 35. 175 divided by 6. 175 divided by 7. 7 and 25. 175 divided by 8. 175 divided by 9. 175 divided by 10. 175 divided by 11. 175 divided by 12. 175 divided by 13. Okay, and now the number I get back is larger than the number I'm trying to divide into. I get 13.4615, so that's it. This is all the possible factors. 1, 5, 7, 25, 35, and 75. 1, 5, 7, 25, 35, and 175. All right, now let's list all the possible factors of our leading term, okay, which is 3, and that's pretty easy because it's only 1 and 3. All right, now what we're going to do is we're going to put every one of these possible numerators over every one of the possible denominators, and we're also going to do plus or minus. All right, so my possible rational zeros, plus or minus 1 over 1, plus or minus 5 over 1, plus or minus 7 over 1, plus or minus 25 over 1, plus or minus 35 over 1, plus or minus 175 over 1. Okay, and now I'm going to do all of these over 3. So plus or minus 1 over 3, plus or minus 5 over 3, plus or minus 7 over 3, plus or minus 25 over 3, plus or minus 35 over 3, and plus or minus 175 over 3. Okay, it would be better if I could put them all on the same line, but I kind of ran out of space, so I put some on one line and some on the other. Okay, next let's go ahead and let's simplify. Okay, and if we have any duplicates, we're going to throw out the duplicates because we don't need those. All right, anything over 1 is just itself, so plus or minus 1, plus or minus 5, plus or minus 7, plus or minus 25, plus or minus 35, plus or minus 175, plus or minus 1/3, that does not reduce, plus or minus 5/3, that does not reduce, plus or minus 7/3 does not reduce, plus or minus 25 over 3, that does not reduce, plus or minus 35 over 3, that does not reduce, and plus or minus 175 over 3 also does not reduce. Interesting. Okay, here are all of my possible rational zeros. Now I want you to pause this video and I want you to stop. Ask yourself, how many possible rational zeros are there? Okay, pause it now. Count them up. All right, if you said 12, that is not correct. There are 12 positives and then 12 negatives. So there's actually 24 possible rational zeros. All right, now part B of this problem is going to ask you to use synthetic division to find one actual zero. So there's 24 possibilities. It might take a while. Hopefully we'll hit one within the first few tries.